Good morning. So we're going to go through a introduction to organic chemistry. Hopefully at this point you've watched the little video with the animations. It was about a 15-minute TED Talk, and it was a nice introduction to what organic chemistry is and how it's all around us in our lives. After that, you should have gone over the basics of drawing simple hydrocarbons using line, condensed, and structural diagrams. And here's where we'll start to put everything together and understand kind of what the formulas mean and where the names are related to the number of atoms. So our learning goals here are pretty straightforward. We want to be able to draw the first 10 alkanes, and we'll talk about what that means. Over the next lesson or two, we'll get into different types of organic molecules. We really want to be able to use those structural, condensed, and line diagrams to represent these. So that's our goal for the first portion here. A couple of different molecules here. You can see these are big and complex molecules. They serve a bunch of different purposes. And the interesting part is that all of these are found in nature. So there's a lot of applications in different plants that we may have or may not have. So part of what we do when we study organic chemistry is look to nature for what's hiding and how we can use it in our lives. So a simple definition of organic chemistry is the study of carbon, including its structure, function, and reactivity. All right, a lot of this comes from carbon-carbon multiple bonds. You can see here like a double bond. Carbon-oxygen bonds, that's a very reactive one. And carbon plus an electronegative atom. So anything like oxygen, chlorine, fluorine, etc. We'll look at that when we get into reactivity, but our goal here is just be able to draw and interpret what the molecules look like. So a hydrocarbon is a molecule that just has hydrogen and carbon in it. There's two types, saturated and unsaturated. There's actually many types, but we'll break it down into these two for now. So saturated hydrocarbons have all single bonds. Unsaturated hydrocarbons contain some kind of multiple bond, so either a double or a triple bond between the carbons somewhere. And we always try to remember that carbon can form 4 bonds, hydrogen can form 1. We're not looking at exceptions to the octet here. We're focusing on just the normal behavior of carbon. All right, and you can see some bond angle and bond lengths. That's more once we get comfortable with what a hydrocarbon actually is. So for now, we just want to be able to read this. Okay, properties of hydrocarbons. Actually, if I jump back here quickly, when we're looking at these are called structural diagrams. We'll look at writing the formulas for them as well. And there are a bunch of different ways to do that. But generally, we look at how many carbons there are, state that first, and then beside that, we'll write how many hydrogens. And that gives us a good idea as to what the structure can be. Okay, and there's many ways to do this. So very briefly, the state of a hydrocarbon depends on how long the chain is and what's attached to it. So they can be gases, liquids, or solids. Vapors, which is the gas particles, combust easily. Liquid hydrocarbons will not combust. So a good example of this is the gas tank in your car. Liquid octane or liquid gasoline will not combust. It's only when the vapors form that there'll be some kind of explosion or burning from it. So when we talk about hydrocarbons, we're going to look at the 10 most common ones, all right? And these are named based on their prefixes. So the prefixes correlate to a number. And when we name them, we look at the chain of hydrocarbons, which we'll see with some pictures. So any hydrocarbon that starts with the name meth, and the dash just represents what type of bonding it has attached after it, means that there's one carbon as the central chain. And then Eth2, prop3, but4, penthexheptoctanon, and dec. So you can see up till about 4 carbons, they have proprietary names. So meth, eth, prop, and but. But after that, they kind of take on their geometric shape. Like if you see pent, you probably think of a pentagon, which is a 5-sided shape, and that's how many carbons there are. So the names give us a hint as to how many carbons there are in the molecule. That's what we're trying to get across here. And we need to know up to 10. So we're going to draw them 3 different ways, and hopefully you would have done this module already. If you go back to D2L and do the introduction to drawing different types of diagrams. That's a great first video to watch before you move on. And it goes over how to draw a structural, a condensed, and a line diagram. So I'll skip past here on this case, but you'll definitely want to go back and watch that if you're not comfortable with it yet. Okay. Line diagrams are what our goal is in the end. They show a lot of information by showing less information. So you only see the carbons in a line diagram. Every point represents a carbon where the line changes direction. So in this case, we have 6 points, which means we have a 6-carbon chain. The zigzagging is because all the carbons in the hydrocarbons are tetrahedral, right? So you can see that zigzag pattern right here. And the hydrogens are usually drawn in 3D, which is why we leave those off. So the main bonding between carbon atoms is what gets shown in the line diagram, and we remove the hydrogens because they're not reactive and they don't affect the shape at this point. Okay. One other link, because there are 6 carbons here, right? We can imagine that this carbon is going to start with the prefix hex, and we'll learn about what the ending ANE means in a couple of slides. Functional groups are things that get attached to the carbon. We're going to study these after we get the basics of just hydrocarbons down. And these change the properties and the reactivity of the hydrocarbon. They can make them safer, more soluble, more useful. It all depends on what's being attached. So for now, what we need to know is that depending on what the structure looks like, we want to remember that carbon forms 4 bonds. And if you watched that video before this, you would have seen the acronym HONC, H-O-N-C, 1, 2, 3, 4. It's very important to remember this because it gives us a visual cue when we're drawing the molecules as to what they should look like. So now we get to alkanes, and here's what we're going to focus on for this video. So an alkane is a hydrocarbon that only has carbon-carbon single bonds. They always have the formula CN H2N plus 2. So for example, if there are 3 carbons in the chain, there will be 2 times 3 plus 2 hydrogens. So in this case, we'll have 2 times 3 plus 2, which means the formula will be C3H8. And if we go back to that chart, which we'll need to know, anything that has 3 carbons will have a prefix of prop. Okay? Now, if the structure has all single bonds, then the ending is ANE. So in this case, this molecule would be called propane, telling me that there are 3 carbons and they are all carbon-carbon single bonds. That's what the ANE tells us. So an organic molecule's name is many pieces together to give us a clue as to what the structure look like. So in alkanes, all of the carbons are tetrahedral when there's just carbon and hydrogen because they're all single bonds. Okay? We call these saturated. So if I look at some examples, pentane, okay, the ANE tells me that they are all carbon single bonds. Pent is the prefix for 5, and we can see 1, 2, 3, 4, 5 carbons in this molecule. So I would call that pentane. Similar with octane, I see the ANE ending. That tells me carbon-carbon single bonds. And the oct prefix tells me 8 carbons should be in this chain. So as I start numbering, I can see that there are 8. Now, they're not all necessarily connected in a chain, but when we see them with the prefix, that tells us that, yes, they are in a chain. So we'll look at something called branching next. Okay. At this point, if you haven't, please go to D2L and try the worksheet, the first one that's posted, the introduction to drawing different types of diagrams. It's very beneficial to have that done before you move on because I just focus on the basics before we move forward. So assuming that you've done that worksheet, we're going to talk about something called an alkyl group. And essentially what this is a branch on a hydrocarbon chain. So the alkyl groups, they all follow the same prefixes. So a meth group, for example, has 1 carbon on it. And these all end in YL to tell us that they come off of a longer chain of carbon. So for example, if I just draw 5 carbons together here, you would assume that that's a pentane molecule because there are 5 and they're all single bonded. Now, if one of those carbons has a carbon sticking off of it that looks like this, that's called a methyl group. So now there's still one long chain of 5 carbon atoms, but there's branching. So these are more complex molecules now. What this tells us is that the molecules can get bigger, all right? And the methyl group is essentially like a methane, but it's lost one hydrogen because it needs to attach itself to the main chain. Similar with something with longer carbons. So pent-2-il, again, we look at all of this. The first part tells me that there are 5 carbons. The ending tells me that it's a branch off of a chain of carbons. And this number tells me that at C2, it attaches to the main branch. So 1, 2, 3, 4, 5. That means this carbon here will attach to a longer chain and form very complex branching. So if we do an example of this, we'll start off with a name and we're going to break it down. Okay, I can see lots of different parts to it, so let's just break this down into pieces first. I always want to look for the ANE ending because that tells me what the chain I'm starting with first is. So that tells me that ANE means all carbon single bonds. I'll work my way kind of from right to left here. But tells me that there are 4 carbons in that chain. Okay, so I can start with this. 1, 2, 3, 4, and they're all single bonded. I see the YL ending, which tells me there's branching, and the Eth tells me that it's a 2 carbon branch. Okay, using all of these names together. Now the last thing I need to know is that this branch is on carbon number 2 of the main chain. So I've got my chain here of 1, 2, 3, 4 carbon atoms. That's the butane molecule. But on carbon 2, I'm going to have a 2 carbon chain. That's the ethyl group. Now from here, all I need to do is fill in my hydrogens. So we'll do a structural diagram for this for us to see first. Right, I'm making sure that each carbon has 4 bonds. And you can see how complex this gets. Okay, so there's our structure. If I want to do a condensed structural formula, I can draw a line here and I can do this. Remember, everything to the right is what's attached to the carbon. So CH, CH2, CH3. We can use the dash or we don't have to. And then up here, I showed the branching like this. So there's lots of different ways to represent this. Finally, if I'd like to do a line diagram, I'll start with the main chain again, which is 4 carbons. So 1, 2, 3, 4. And then on carbon number 2, 1, 2. And I try to keep that zigzag pattern. So all of these represent the same molecule, but in different ways with different information. Okay, so make sure you start off with the structural diagram to understand all of the bonding, and then move to remove it as you get comfortable with that. So overall, these are a list of rules that we follow when we're naming, and we'll get to some examples after this. But we want to start off by identifying the longest carbon chain. That's called our parent chain. We want to make sure that the name of that parent chain matches the prefix and the number of carbon groups that represents. We want to identify if there are any branching off the main chains. Okay, if there are multiple of the same branch, we'll use prefixes to show that. So we'll give an example of that later on. When there are multiple branches of different types, we'll put them in alphabetical order. Okay, so for example, if I have a methyl and an ethyl branch, then the ethyl will come first in the name. Okay, we do not use the prefixes to do this. Lastly, when we're showing position of something on a molecule, we'll make sure that we use commas between numbers and a dash between letters and numbers. Okay, so for example, if I write a name that has 2 branches on carbon number 2 of a chain, I'll put a comma there. But when I'm telling somebody what is on carbon 2, I'll put a dash between the number and the letter. Okay? So these are all the rules we follow. These are the international rules. When I refer to something, this is where they're coming from. And there's also a large PDF document on D2L if you'd like to see the technical aspects of all of those, but these are more than enough to help us start off in our journey here. So we're going to go to the handout. Okay, this is naming organic hydrocarbons. And what we'd like to do with this is just get comfortable identifying some molecules. So I'll go through a few here. Right, when we see an organic molecule, the first thing we have to do is identify the longest chain of carbons. Okay, so I'll start off that with a highlighter. And to do that, I'll start at one end of the molecule and see how many in a row I can get before there's some branching. So for number 1, I've got 1, 2, 3, 4, 5, 6, 7, 8. So all of those molecules are in a chain. There was no branching, so they're all connected. Right, from here, just clean up our colors. I want to look at the type of bonding. So they are all carbon-carbon single bonds. We counted that there are 8 carbons and there's no branching. So I'd use my prefix for 8, which is oct, and the ending for single bonds, which is ane. And this molecule is called octane. So we'll do the second one now. So here I have some branching. I can see that's not just a continual chain. So I'm going to try and connect the most carbons that I can in a row. So if I start on the left here, 1, 2, 3, 4, 5. If I go down, I'm going to stop at 6. But if I keep going, I can go to 6, 7, 8. Okay, so I was able to highlight a 8 carbon chain as my longest one. Okay. I can see that there are 2 branches coming off of this chain. Okay, so I'll highlight those. And now I'm just going to make some notes off to the side. So there's an 8 carbon chain with carbon-carbon single bonds. So I know that for that I'll have octane again. Now, if I number the carbons, 1, 2, 3, 4, 5, 6, 7, 8, I can see that on carbon 2 and on carbon 5, I have branching. So I'll say here, on carbon 2 and carbon 5, I have a 1 carbon branch. So because there's 1 carbon, I call that meth. And because it's a branch, I use the YL ending. Okay. So when I go to put this name together now, and this is about as complex as it gets, so bear with it if you're wondering how many things we'll have to add. It does build up quite a bit. So we'll start off by writing the parent name, which is octane. Okay. And then I've got to show position. So I've got 2 and 5 here. That means on carbon 2 and carbon 5, there's a methyl group. So I'll write that like this, 2, 5. Oh, we're just going to need some more room here. So clean that up. And because there are 2 of them, I've got to put a di prefix in front of it. So this is going to end up looking like this, 2, 5, di, methyl octane. And this example is nice because it includes a little bit of everything that you'll need to know how to do. So what you're encouraged to do is try examples 8, 9, and 10 from this sheet here and refer back. Don't go further than that yet because we're going to break those down into different types of compounds each day. So we'll focus on one type of molecule per lesson. And check the answer guide that's on D2L for this as well until you're comfortable drawing all of the molecules. Your textbook, okay, so again, all these different types, don't go through these until you're comfortable with the alkanes. These are all the individual lessons, right? You'll really want to focus on drawing the alkane molecules from chapter 1.1 before you move on to alkenes or any other topics.